This video is for section 10.3 in Trig. So we covered the law of cosines and the law of sines. We decided that they could be used when we had at least two sides and at least two angles. So the last case is the ambiguous case, which is the one that goes angle, side, side. If you think about that acronym, you see why we're not allowed to do that one, angle, side, side. So because of that, they usually label it instead as side, side, angle to avoid that. So the reason that it's weird is because it actually does not prove two similar triangles. You can get we can get two completely different triangles with these three exact same pieces of information. And I know that seems weird, so they kind of have these two diagrams here, and we're also going to look at a little video. So if I had an angle that was known, so side A is the same as side A, and then I knew that this side length was such and such, and this side length was such and such, there's actually a way that you can swing this side A and create two different triangles. So let's look at our little video here. So if we share this page, let's see, here we go. All right, so I gave you the link on your XYZ here. Actually, let me show you that first. So you can find this on your own and play with it. So right here, this little link right here, you can type this in and you can find this exact same little video. You can play with this cool ambiguous triangle. So what happens is if we knew this angle was set as 30 degrees, and then we knew this side was a certain length and this side was a certain length, one of three things would happen. This would be one of the cases where actually you can see that no matter what, that A would never actually connect. So if you knew that this angle had to be 30 degrees, there's no way you could make a triangle that does that. So you can see it swinging there, it never crosses this line, it never forms the three sides of a triangle. So another one of the cases would be as if you had exactly, let's see, pause it right. Okay, so right there. So if it was an exact perfect right triangle, and then right there, we would have a perfect right triangle, and there's only one way that would have worked out. So that would be that 30, 60, 90, everything would be great. So that's the best case, but there's one more. So if you have, here we go, this case right here. So here we can see the video. See it swinging back and forth between these two triangles. So we have triangle A, B2, and C, so this bigger triangle connecting these 3 points. And we have triangle A, B1, and C. And both of these triangles would have these same three pieces of information. So that's why this one is sneaky. Both of them have an angle A of 30 degrees. Both of them have a side B length of 4.5, and both of them have a side A across from angle A, length of 3. But that 3 could swing out to be here and be this obtuse triangle, or this 3 could swing in here where B1 was the obtuse triangle. We have these three separate cases. So that's why you have to be careful. So let's watch it again. So there it is swinging. So that stays the same length of 3, but it hit those two different points. So that's why we created two completely separate triangles. So back over to our PowerPoint here, not our PowerPoint, our notebook. Okay, so it has these three cases kind of laid out for you. So it could be that perfect one right triangle where A exactly matches it, and then the angle A here, and the side C and the side A are known, and it all works out. It could be that one we started with where the A was kind of swinging, but it never attached down here, so you couldn't make a triangle. So when you do the math on those, what you end up with is like negative, side lengths and stuff like that, where it's obvious that things aren't working out right. And then the other case is those two triangles like this right here. So where the A could swing back and forth and create two different triangles where either we had an obtuse angle here or possibly an obtuse angle here. So this one is the last variation where again only one triangle was possible, just the way that the numbers worked out. So this right here was obtuse. So even if you swung the A, it wouldn't meet back up over here. I think we could make our video do that too, but basically 1, 2, or none cases is what we're looking for. So let's try it out with the numbers. So that's, graphically what's happening. But when you're working with the numbers, it all just kind of makes sense. Now, most of the time that you see this ambiguous case in a lesson, you'll be shown the sign method, the law of signs, and that works. And they talk about the fact that, you can do your proportions just like we were doing before. But when you have an unknown angle, you end up doing an arc sine, and the arc sine could be in quadrants 1 or 2. So you have to go in and find which one of those two quadrants would work out. Things get a little confusing. So there's actually another way that we can use our law of cosines that we learned in 10.1. And then it all just ends up working itself out with the quadratic formula, which we can use our quad program for. So keep your calculator handy. So in this one, we are given the angle and a side and a side. And I know it's this ambiguous case because it has the angle and then one of the sides and then the side across from that angle. So that's why it's angle, side, side. Now remember in lesson 1, I told you that as long as we have at least two sides, we can use the law of cosines. That's still true. And as long as you're using the law of cosines, it just works itself out. So if you don't remember if you have the ambiguous case or not, if you're using your law of cosines, it doesn't really matter. It's all going to work itself out. So here we go. Let's try it out. Our law of cosines, if you remember, here's the refresher. Okay, was the a squared equals b squared plus c squared minus 2bc cosine a. Okay, so we said we could use it for any one of the three as long as we matched them up, the a to the a. And back when we covered that lesson, we also found that the equation could be tweaked so that we could find the angle is the arc cosine. And we said we just had to match up again the a to the a. So the only one that was subtracted matched up to that angle. So we're going to use these two kind of variations. So kind of keep those handy. All right. So we have angle A, side A, and side B. So I just have to make sure that I match up angle A and side A. So if I have angle A, I'm going to put my side A right here. So I'm going to start with my 0.84 squared equals, and then I'm going to have my side B squared plus C squared. Now C is the one I don't know, so I'm going to leave him as the variable C. That would be minus 2 times B times C, okay, variable C, cosine of angle A. Okay, so we can be careful. This is variable C, this is cosine, so I know there's two C's there. So right here, I have a bunch of numbers and then one variable. Remember again that cosine of 53 is just a weird decimal, so I really only have a quadratic formula. So from there, I can tweak it. I can get it equal to 0 by subtracting this guy over. There we go. And I can put it in order so that that c squared's up here in the front. Here's my variable c next. And then the constant back here in the back. And then I'd have my quadratic formula. All right, so when we're doing this, the only calculation we really need to do offhand, since we use that quad program, is doing 2 times 0.88. So just doing that part. 2 times 0.88 gives me 1.76. Okay, remember this was a negative. And then we're just going to leave cosine as cosine of 53. Okay, so that's my B. And then C would be the constant right here by taking 0.88 squared minus 0.84 squared. So doing just that calculation, I get that it's positive 0.0688. Okay, so all I did is 2 times this decimal, and I did this subtraction right here. That was an 8.4. I know it looks a little like an 8.9. And if you're using that quad program, you can type it all in just like that. So remember, go to Programs, Alpha 9 to get to quad, hit Enter to run it. Your A is just 1, okay, because there's only one C squared. B is this, which you can type in just like that. So I use the little negative on the bottom, and then I type in the 1.76, and then I just hit cosine of 53. Remember to make sure that you're in degrees before you start these problems, but you're probably still in degrees. Okay, so it should look just like that. Just literally type in the cosine. You don't have to hit enter or anything. And then when you hit enter, it brings you to C, which was at 0.0688. I hit enter, and it gives me the 2 decimals right there. Okay, so now I see that C could be 0.98968, or C could be 0.06. Let me change his color over here. 0.069518. Okay, so these are the 2 separate answers from running quad. In fact, it's even easier than that, because once you run quad, you didn't even really have to do this calculation. So what you could have done from the very beginning is say, okay, once I get this set up right here, I'm going to run quad. I know that my A is 1 because it's next to the C squared. My B, I could type in this whole thing. So I could type in -2 times 0.88 cosine 53. So I didn't even have to do that multiplication. I could type it in just like that, and it'll take care of it. And then for part C, the constant, I really didn't even have to do this. So right here in C, I could actually just literally type in 0.88 squared minus 0.84 squared right there on this screen without having to do that decimal first. Okay. When I hit enter, there's those same 2 numbers. So I could have gotten away without doing hardly any math on my own. I just run it in quad. So the main thing that I have to do is I do need to make sure that I've got it lined up where the side A was across from the angle A. That's pretty much the only way you can mess it up. So if I had angle A of 53, I just had to make sure I put the 84 on this side and the 88 on this side, and everything else works out. All right, so those are 2 of my answers. It wanted to know all of the solutions. Now, what if it wanted to know everything else? Okay, what if it wanted the rest of the angles? So remember that my angles were found with that kind of tweak that we said. Okay, so I could find angle B. Let's find angle C. No, you're right. Angle B, angle B. There we go. Okay, so using that arc cosine that we had done from a previous lesson, remember that that means the B is going to be the one that's minused in the back there. So I would have my A, which was 0.84 squared, plus the C. Okay, just to avoid rounding error, I'm going to type the whole thing. 968 squared minus the B squared. 0.88. As long as you remember to match up that one, B and B, everything else works out. All over 2 times A times C. Remember on the bottom here that they're not squared. It's just these numbers. Okay, now if you remember, it was easiest to go ahead and get the top part as an answer, then get the bottom part as an answer, and then do the cosine. That helps you avoid any, misplaced parentheses. So just make sure, just type in just the top part here, and that should give you right around 0.5. Nope, right around. I did the other one. Okay, I have to redo this one. Okay, so 0.84 squared is 0.98968 squared minus 0.88 squared. Okay, so I get 0.910665. Okay, 910665. Okay, and then on the bottom, by doing 2 times 0.84 times 0.98968, I get 1.66266. Okay, and then I do my arc cosine. If you can, try to scroll up and recall those values, and then you won't have any rounding error. So the 0.91 divided by the 1.66, and that should finally give you that B is 56.8 degrees. Okay. All right, so if that's angle B, then the only thing left is angle C, okay? And remember, that's the easiest one to find because I just subtract from 180. So C would be 180 minus the 53 that I knew from the very beginning, minus the 56.8, which would give me 70.2. Okay, now a quick check. Remember, the biggest angle is across from the longest side. So I have the three angles now, 53, 56, and 70. 70 is the biggest, and sure enough, this one is the longest side. Okay, so just a really quick check. All right, now what was sneaky is, remember back here, our quad gave us these two answers. These were those two separate triangles. So this one, the other one, had a very small angle. So that one would be like this case, where it kind of swung in and it made this little teeny tiny angle right here. All right, so let's see what would have worked out if this had been my C. Okay, so either my three answers are here in orange, or I might have this completely separate triangle here in purple. Okay, so I'm going to do the same exact thing. I still have B, still the arc cosine. The only thing that's different is instead of this decimal here, I'm going to use this decimal here. 518 minus the 0.88. Two times the 0.84. Not 89. Times the 0.069518. Okay. So then again, just find the top and the bottom parts. So typing in the 0.84 squared, and then plus 0.069518 squared minus 0.88 squared. Okay. This gives me okay, so that gave me negative. Negative's okay, don't worry. 0.063967. Okay, again, remember, if you can, just keep that in your calculator so that you can scroll up to it. That's so much better. And then this one was 0.11679. And when I do the arc cosine of those right there, I get that B is finally equal to 123.2. All right, so then last, what about angle C? So angle C was just the difference from 180 to minus the given 53, which gives me the final angle C as the super tiny 3.8. Okay, so let's make sure that makes sense. So this time, my side C was very much the smallest side, and then he's across from the very much smallest angle. Side B has a much bigger angle, and it's across from the bigger side. Okay. So these were my two completely separate triangles. The purple one would look something like this. Remember, it has the same A, same side A, and the same side B. And this one had a B. A, B. So this one would look something like, right. Okay, with a very obtuse angle. So there's my angle A, my side A, and that's why side angle B was so big. And then the orange triangle would have looked something like this with the same angle A, same length B, and the same length A, but it went down like this and made a more kind of normally looking triangle. Okay. All right. So don't worry, most of the problems don't actually ask you to find all 6 pieces of information for these. They would just ask you for the 2 different C's. But I just wanted you to kind of see the whole picture here, the 2 different triangles that we were forming. So in this next one, let's just find the 2 different side C's. So this one we have the minutes again, but remember, don't panic. We're just going to rewrite it as 29 plus 20 out of 60. Because remember, there's 60 minutes in a whole degree. Okay, and just every time I need angle A, I just type it in exactly like that. Okay, so it starts out the same. Just remember to make sure that you pair those up. So then A squared is the 2.04. Since I know angle A, I know that one's got to go on this side. Okay, equals B squared, 2.4. Be careful, they're going to try to trick you. See how they're very similar? Squared plus C squared minus 2B C cosine of angle A. Remember, angle A, I'm going to write it as this broken up, 29 plus 20 over 60. Okay, and now we can actually go straight to quad. Okay, so remember, when we're typing this into quad, my A is going to be 1. I'm going to write that because then it'll look like the triangle A. You'll know what I mean. So in your calculator, A is going to be 1. The B is all of this stuff here next to the single variable. Okay, so I would just literally type in -2 times 2.4 times cosine of 29 plus 20 over 60. Hit enter. And then side C is the difference. Remember, I always need it equal to 0. So it'd be 2.4 squared minus 2.04 squared. Just type it all right there in that C box. Okay. And then that should give you these 2 options for C. 3.759. That would be 4. And C would be equal to the little tiny decimal point 425.175. XYZ, that's all they would ask you to find. If you just wanted some extra practice and you wanted to compare these triangles, you would find that angle C would end up being 115.47 and angle B would end up being 35.2. For this one, you would find an angle C across from this little decimal of only 5.86. And angle B would now be the biggest obtuse angle at 144.8. Okay. So just to kind of check yourselves if you happen to be just looking for some extra information there. All right, so one more like this. So in this one, again, they give us the same pairs of A, but just be careful that you always match those up. So my A right here is 51.3. Squared equals B squared, 49.4, plus C squared minus 2 times B times C, which is still the variable, cosine of A. Okay, So this one, when I type it into quad, I would end up with the c squared. I would have this one, which again, you could just type it in just like it is. But if you did do the calculation, that would give you negative 98.8. That would be your B, and then your C, your constant, would end up being negative 191.33. Okay, so when you type that into quad, you should get a C of 4.3 and a C of negative 44.486. But wait, remember this is the length of the side. So can we have a length of side of negative 44? No. So this is one of those cases where either if you tried to swing it out the other way, it would go backwards, or it might be an exact right angle where it only formed one triangle. Either way, our answer is the one and only C of 4.3. Okay. So just for a little bit of extra practice, if I did need to find all the pieces of the information here, then I would find my side C, okay, by saying that would be the arc cosine of, remember to pair it up. So if I'm finding side C, then side C is going to go in the back here. So that'll be the minus 4.3 squared. So I would have the A squared plus the B squared minus the C squared. Over to A, B. C is the one that's not down there in the bottom. Okay, remember to find just those decimals first so that you don't mess up any parentheses, because it's really easy to do. You should get 50.56 over 50.68.44. The arc cosine of is 4.39 or 4.4-ish. So this is angle C, or you might call it angle gamma. Okay. Capital C. That's little side C. So then the last one is always the easiest to find because we just have to subtract from 180 minus the original known 114 minus the one we just found, that little tiny angle of 4.39 or 4.4. Which means our final B would be 61.61. And I didn't have to do it twice because this one was negative, so it didn't work out. That one wouldn't have been an actual triangle. And then, of course, everyone's favorite, the word problem. All right, I like this one. It's kind of cool. So it says that after a windstorm, he thinks his windmill might be leaning, but he's not sure. And he can actually find out by just knowing that the windmill is 32 feet high. Let's draw it so it looks like it's leaning. So he thinks it's leaning. That's a little bit of a lean there. I'm so bad at drawing straight lines. Okay, we're not quite sure. It might be leaning. We know that it's 34 feet high, and he knows he walked 32 feet away from the base. Okay, but he's not sure about this angle right here. That's what's in question. Is it a nice 90-degree angle, or is it leaning? So he says once he gets 32 feet away, he finds his angle of elevation to looking at the top of the windmill there was 49 degrees. So this is that angle side. So it's the ambiguous case. So we got to be careful. There might be two options. Let's see what we've got. So I say, okay, I've got to pair up. Remember to match up the right ones. The 34 is across from the 49. So the 34 is what's going to go on the outside here. Equals 32 squared plus c squared minus 2 times 32 c cosine of the 49. And I can use my quad because that's just going to be c squared minus 64 cosine 49 c, and then 32 squared minus 34 squared gives me negative 132. Type that into quad, which gives me two options. It says that then so this one, remember, is actually finding a side C right here. So this one is finding this right here. So it's not finding what I need just yet, but I'm getting there. So side C then would be either 44.926 or negative 2.94. Side C is obviously not negative, he's out. So this is the only one I care about. So I'm not quite there yet. I can't tell if the windmill's leaning, but now I know the side across from the angle I need. So now I can use that angle formula. So angle X is going to be the arc cosine of, remember to make sure it's across from the one that we need. So it's going to be the 32 squared, the 34 squared, and then last side C across from side X is in the back. So that was the 44.926 squared over 2 times the 34 times the 32, which is equal to the arc cosine of 161.654524 over 2176. Type that in to get an angle X of 85.74. So this angle is 85. That is not 90. That means yes, his tower is leaning. It's got to do some repairs. How would you repair a leaning windmill? All right. So here's just kind of a recap of those three cases, but remember that as long as you had at least two sides, you could use the law of cosines. That one works out the easiest as long as you have that quad program. If you watch any of their videos, they'll probably show you these same problems using the law of sines. You're welcome to do so on the test. I wouldn't count off for you or anything, but just whatever works best in your mind. As always, let me know if you have questions.